Today we're looking at solving simultaneous equations using another method called elimination. So that's pretty much our learning intention again, to be able to use this elimination method. So the things that we want to be able to do by the end of this is firstly, to determine what operation you need to eliminate a pronumeral from the simultaneous equations to start off this elimination. Then to find the solution, but also looking back at substitution and elimination, working out which is the best method to solve a pair of simultaneous equations. So when we're looking at elimination, what we want to do, when we want to use elimination, we want to be looking at a pair of equations that are given in the same format. Okay, so if it's the x and the y's together and the number on the right-hand side, we want the equation to look like that. Or if we've got an x on one side and then y and a number on the other side, we want the other equation to mirror that as well. And what we can do is we can eliminate a pronumeral by adding or subtracting the equations vertically. Okay, so if they're in exactly the same format, you've got the x's lined up, the y's lined up, and the numbers lined up. So if we add or subtract them downwards, then our goal is to try completely eliminate one of those pronumerals. So here's a couple of hints as to how to go about this. So the steps are pretty much similar to your substitution. You want to name your equations and then write out the operations that you're doing and then solve for one of the pronumerals. Then you're going to substitute that back into an original equation to find the other value. Okay, so you can pretty much follow what we did in the substitution. But when we're going about working out how to eliminate, here's a couple of hints. So the first thing would be to choose the variable with the same coefficient. So look at the number in front of it. If the number, so don't worry about the magnitude, so positive or negative, if the number itself is the same, that's probably the best one to cancel. Okay, if we can't find a pronumeral with the same coefficient, what we need to do is multiply one or both equations by constants, so by a number, in order to make it happen. When we're looking at the equations then, with the letters with the pronumerals the same coefficient, now we look at the sign. So if one's a positive and one's a negative, then what we're going to do is add those equations together. So if the coefficients are opposite in sign. If the coefficients have the same sign, so they're both positive or both negative, then we're going to subtract the equations. So think about if you've got like a 4 and a 4, to cancel them off, you need to subtract them. But if you've got a 7 and a negative 7, you can see if you add those numbers together, that will cancel them off. So let's have a look at a couple of equations, a couple of examples. So with the first one, solving these equations, first thing that we're going to do is we're going to label them. So equation 1, equation 2. If you want, you can use A and B as well, or like I and II, Roman numerals. It's up to you what you want to use. Now, when we're looking at these equations, we need to first work out what letter to eliminate. Now, if we look at the Q's, we've got a 4 and a negative 1, so that's not going to be very useful. But if we look at the R's, we've got positive 3R and negative 3R. You can see that the coefficient, so the number component, is the same, even though we've got different signs there. So that's going to be the pronumeral that we're going to eliminate. Now, because the signs are opposite, what that tells me is if I add those two values together, if I have a 3R and I add a negative 3R to it, that's going to cancel them. So we're going to take equation 1 and plus equation 2. So that's the steps that we're going to do. So what you could do is you can rule it off and put a plus there so you remember what you're doing. And so what we're going to do is we're going to take the 4Q plus negative Q. That's going to be 3Q. If I add those values together, positive 3R plus negative 3R is 0. So we don't need to write anything. And then on the other side of the equals, 8 plus 7 is 15. So you can see we're adding them and subtracting vertically because these are like terms, these are like terms, these are like terms. So now that we've eliminated r, we can now simply solve this, divide by 3, q is equal to 5. Now we've got one of our values. What we need to also do is find the other value as well. Make sure you don't forget the other value. So what we need to do is we're going to put q equals to 5 into either of equation 1 or equation 2. So it doesn't matter which one you choose to put into again, okay, because the other one would be useful for a check. So what I might do is I might sub this into, I might go with equation 1, only because I've got positive numbers, okay? So like you always try to find shortcuts. Ultimately, it doesn't really matter too much. So if I put into equation 1, 4 times 5 plus 3r equals to 8. So that's 20 plus 3r is 8. Subtract the 20, 3r is negative 12. So r is equal to negative 4. So we've got q equals to 5 and r equals to 4, negative 4. What we can do is, if we want to, we can check it by substituting into 2. So the check, what I've got is negative 5 minus 3 times negative 4. So that's negative 5 plus 12, which is 7. So we can see that that's correct. Now, because we've got q and r, now usually with coordinates we wanted to use x and y. So it's actually better to write this solution separately. So therefore q equals to 5, r equals to negative 4. Okay, so that sort of saves writing it as a coordinate and then getting them mixed up, or like if you have them in the wrong order, you could get that wrong as well. Okay, so you just write them out explicitly. Let's have a look at the next one. So when we're looking at these equations, again, equation 1, equation 2. So when we're looking at these two equations, what you can see is that x values have the same coefficient. Now, we've got a 5 and a 2 on the e, so that's not going to be very useful. So what we want to do is we want to eliminate the x's. Okay, so we've got 3x and 3x. You can see that they're both positive. So what we're going to do is we're going to subtract these equations. So we're going to take equation 1 minus equation 2. So we can rule it off if you want and then put a minus there. So 3x minus 3x is equal to 0, so it disappears. We've got 5e minus negative 2. So two negatives make a positive, so that's 7e. And then we've got 16 minus negative 5, so it's 16 plus 5, which is 21. Then we can divide by 7, e is equal to 3. Now from there, again, we can substitute into either of those equations. For this one, it doesn't really matter which one you choose to use. I might just put it into equation 1 again. Sub into equation 1. So we've got 3x plus 5 times 3 equals to 16. 3x plus 15 equals to 16. 3x equals to 1, so x is equal to 1/3. So that's our solution there. What we can then do is check it. So with our check, we're going to substitute into equation 2. So we've got 3 times 1/3 minus 2 times 3. That's 1 minus 6, which is negative 5. So you can see that that's going to be correct. So then therefore, e equals to 3 and x equals to 1/3. So again, if you tried to graph this on a number plane, what you'll find is it will be very hard to actually say definitively that x is equal to 1/3. So the algebraic method allows us to find the solutions with accuracy. All right, here's a couple more. There's lots of different ways that these questions can be asked, so it's important that you look at a variety. So with this question, we've got 3w plus q is 6. 2w minus 3q is 15. So first thing, let's label these equations. Now, if you look at these equations, The W's have coefficients of 3 and 2, so they're not the same. The Q has a coefficient of 1 and -3. They're not the same either. So we've got a bit of a problem here. None of the coefficients are the same. So what we'll need to do is make one of the coefficients makes the coefficients the same for one of the variables by multiplying by a constant, so some sort of number. Now, when we're looking at these questions, we need to then work out, do I want to eliminate W's or do I want to eliminate Q's? Now, ultimately, it doesn't matter which one you choose, but I'm actually going to choose the Q's. The reason for that is because the top Q has a coefficient of 1, it means that I can easily change that into a 3. Okay, so in other words, all I need to do is I'll only need to manipulate the first equation and then I can go and eliminate them. If I wanted to eliminate the W's, what I'll need to do is I'll need to change the 3W and I'll need to change the 2W in order to get them to eliminate. So what I'm going to do is I'm going to take that first equation and I'm going to multiply it by 3. So then I've got a 3Q there. So I'm going to go 3 times equation 1. So you can see it's always important to write out what you're doing so that the marker can see, okay, this is where they've gotten this number from, this is where they've gotten this number from. So if I multiply equation 1 by 3, I'm multiplying every single term. So I've got 9W plus 3Q equals to 18. Everything is multiplied by 3. What I'm then going to do is I'm going to rewrite equation 2 underneath so that I can rule it off and cross out stuff. So we had 2W minus 3Q equals to 15. So I'm going to label these. This one's going to be equation 3, up to 3 now, and that was equation 2. So when we're looking at these equations, we can see that the Q's now have the same coefficient but are opposite in sign. So we're going to take equation 3 plus equation 2. So when we add that together, we're going to take the W's, add those, so that's 11W. When I add the Q's, they disappear, and then 18 plus 15 is 33. Then we divide by 11, so W is equal to 3. So we found one of the polynomials. Now from here, you know how we've got equation 1, equation 2, and now we've also got this equation 3. We can put W equals to 3 in any of those 3 equations now. Obviously, we probably won't put it into equation 3 because you do have really big numbers there. So we're just going to pick one of those ones. I'll probably go with equation 1 because Q has a coefficient of 1. Once I've done this substitution, once I've moved it, I've got my answer. So I'm going to sub into equation 1. So that's 3 times 3 plus Q equals to 6. 9 plus Q is 6. So Q is equal to -3. So if I went and substituted into the second equation, when I move the W over, I'll still need to divide by the -3. So some of these shortcuts will help you when solving these questions. Main thing is it reduces the errors that you make. Okay, so it increases your accuracy because you're not having to do as many steps. But in the end, if you substitute into equation 2, perfectly fine. Just don't make any mistakes. All right, let's check this to make sure that we're all on the right track. So we're going to check by putting into equation 2. So it's 2 times 3 minus 3 times -3. And that's 6 plus 9, which is 15. So we can see that that's correct. So therefore, W is equal to 3 and Q is equal to -3. All right, question D. So label your equations. Now, when we're looking at these ones, if we look at the A's, we've got a coefficient of 5 and a coefficient of 2. So they're different, so that's not going to be much use. But when we go to look at the F's, they're different as well. So what we'll need to do is we'll need to choose one of them to eliminate, and we will need to transform both of those equations. Now from here, it doesn't matter which one you choose. Yeah, like you can just go with A or you could go with F and you'll still get exactly the same answer. I'll probably go with F, I think, just because. Okay, it ultimately doesn't matter. So if I do go with F, my coefficients that I've got at the moment are 2 and 3. So I need to think, what's the common uh, lowest common multiple of 2 and 3? It'll be 6. So what I want to do is I want to transform both of those f's so that they're 6 f's. So if I've already got a 2 in equation 1, I need to multiply that by 3. So I'm going to do 3 times equation 1, and I'm going to write this one out. So that will be 15a plus 6f equals to negative 42. And I'm going to take equation 2 and multiply that by 2. So 2 times equation 2. So when I multiply everything by 2, that's 4a minus 6f equals to 4. So because I've changed these equations, I'm going to call this one equation 3, equation 4. If you want, you can use A, B, C, D. Okay, equation A, B, C, D. That works too. Just make sure that whatever you use for this, it's not the same as the pronumerals in there. So don't get them all muddled up. Okay, as long as you can keep them in distinct. All right, so these F's, you can see that they're different signs. So what we're going to do is add those equations together. Equation 3 plus equation 4. So again, if you want, you can rule it off if you want. You can see it's actually not that hard even if you don't rule them off. Okay, so questions here, I didn't even rule them off. So let's add those together. 15a plus 4a is 19a. The f's cancel, equals to negative 38. When we divide by 19, that's going to come out to be negative 2. So once we've got a value, what we want is to now substitute it into any of those 4 equations. Now we'll probably stick with one of the first 2, okay, because the numbers are a lot smaller. These are just bigger by like a factor of 3 and a factor of 2. I might choose to use equation 1 sub into equation 1. So if I put negative 2 in, then I've got 5 times negative 2 plus 2f equals to negative 14. Negative 10 plus 2f is negative 14. Add the 10 across, 2f is negative 4, so f is equal to negative 2. So we do get the same value, which is pretty cool. Okay, so sometimes your pronumerals could take on the same value, and that's perfectly fine. So let's check that this is indeed the answer. So I'm going to substitute it into equation 2. So it's 2 times negative 2 minus 3 times negative 2. So that's negative 2 plus, negative 4 plus 6, which is 2. So you can see that that's correct. So therefore, our solution is A equals negative 2 and F is also equal to negative 2. So that's how we work with elimination. So as always, try to minimize the amount of work that you need to do. Okay, the less work you're doing, the less algebra you're doing, the more likely you are to get the questions correct. Okay, sometimes it does take a lot of practice in order to work out what's the fastest, the most efficient method. All right, here we're going to talk about choosing the best method. So we did this last year as well. So when we have a pair of simultaneous equations, usually one method is better than the other. Okay, so one method will be more useful or faster to work with than the other method would be. For the most part, you won't be asked specific methods when solving simultaneous equations, but sometimes they can ask it Like we might put an exam question where it's like solve using elimination, just because we want you to make sure that you know how to do it. Or sometimes it's also just to give you a hint as to where to go with it as well. Okay, so usually we will tell you the most efficient one to use, but you'll need to have a look at, like, for the most part, we won't tell you explicitly which version we want you to use. So remember, we just said if we were looking at these equations, so when we were doing elimination, we wanted the equations in the same format. So we want the x's lined up, the y's lined up, and the numbers lined up to some extent. If we're looking at substitution, so if we scroll back up to where we were doing this substitution stuff, what we wanted to have was one variable as the subject. So remember, with these equations, that was really what we were looking for, okay? If we could replace y with an expression, okay, again here, y with an expression. It could be like x with something with y in it as well, okay? But you're looking for an equation where you have one pronoun as the subject. When you're looking at these ones, then what you want to do is you want to check these. So if you look at the first equation, you can see that x and y, and you've got your numbers there. So you can see that it's in the same format. So that means we're going to use elimination. Oops, elimination. With the second equation, you can see you've got m equals to 5 minus k. So if it's 5 minus k, then what we would normally do is we'd replace the m with 5 minus k. So this one we're going to use substitution. And with our last one, we've got this one, and the second one isn't in the same format, but you can see x is the subject. So we're going to use elimination again here. Okay, so those would be the best methods to use, and what you'll find, oh, sorry, not elimination. What am I writing? I think I said substitution. Substitution. Okay, so what you'll find is if you use that particular method, then you'll actually be able to solve these questions a lot easier than if you were to try to convert it into, so say for example, with the first one, if you wanted to try convert one of the equations into a y equals, then there's a lot more work there. If you had to change that one so that it was in the same format, there's a fair bit of work that you'll need to do there as well. Okay, so that's why those would be the best methods to use.